Hello students, welcome back to another lecture of Lakshya tutorial. I am Avishek sir and today we are going to discuss another topic in similarity, that is how the area of similar triangles are related. So let us quickly start with this lecture. Now, let us discuss how the area of similar triangles are related. But before starting with this one, we need to consider two triangles over here. Let us draw the first triangle over here. I'm writing this triangle as A, B, C, and let us draw the another triangle, that is P. Or let me draw this a little bit bigger over here. This would be PQR. Now, if we are considering similar triangles, then in this case we can say that this triangle and this triangle, since they are already similar, we can say that area of triangle ABC by area of triangle PQR. So basically I am taking the ratio of these two triangles and we say that the ratio of the area of the triangles is equals to the square of the similar sides of those triangles. What does that mean? Square of similar sides. So we can all say that this side is similar to this side because we are already considering that they are similar triangles. Since we are considering that similar triangles, then the sides are in ratio. So we can say that this is equals to the side AB by the similar side PQ whole square, or the side BC by QR whole square, or the side AC by PR whole square. So what is the ratio? The ratio is that the ratio of the areas of these two triangles is equals to the similar sides whole square over here. Very simple concept. It is basically the ratio of similar side whole square. Now, since we have already discussed how they are related, let us discuss about the proof of this one. So now we are going to discuss about the proof, how we are getting this result. So let us quickly start with this one. Now let us start with the proof of this one, that means the area of similar triangles. Now what are the things that is already given to us? Let us first discuss that. In this case we have been already given that both the triangles are similar, so that part is already given to you. Now what we need to prove, let us understand that also. We need to prove that area of triangle ABC by area of triangle PQR is basically the side ratio. Ratio of the sides whole square is basically ratio of the sides whole square. Now let us start with the construction over here. So let us write construction. Now what is the construction that we need to do over here? We are basically going to drop perpendicular from the point A on the opposite side BC. Similarly, we are going to drop a perpendicular from the point P to the opposite side PQ. And let us name this point to be M over here and this point to be N over here. So what is the construction? Construction is very simple. We just need to drop a perpendicular from point A and point P on the other side BC and QR, and we name that point to be M and N over here. Now let us write that construction. Draw AM perpendicular to BC and PN perpendicular to QR. So this is the construction. Now let us start with the proof of this one. Now in the proof, since it is already given that these two triangles are similar, we can say that the sides are in the ratio. So we can say that AB by PQ is equals to AC by PR is equals to BC by QR. Given triangle ABC is similar to triangle PQR. So this part was given, so we can say, and we will name this as point number 1. Clear? Because we are basically going to use this. Now, since we have already considered this point, let us consider another triangle over here. In this case, we are considering the triangle ABM and PQN. Let us start with this one. Now let us consider the triangle ABM over here and the triangle PQN over here. So we can say that in triangle ABM and triangle PQN. So we are basically considering these two triangles. In these two triangles, the first point is angle AMB is equals to angle PNQ is equals to 90 degree. So first thing that we are saying that this angle is equals to this angle, that is equals to 90 degree over here. Or let me write this by construction. I'm writing in short by construction over here. So this is the first point. Now let us start with the second point over here. The second point is that angle B is equals to angle Q. Since we have already discussed that these two triangles are similar, and in the case of similar triangles the angles are equal and the sides are in ratio. So from this one we can say that angle B is equals to angle Q, since triangle ABC is similar to triangle PQR. So this part is already known, so we can say that the angles are equal. Now in this particular triangle, since two angle is already equal, what are they? Angle B, angle Q, they are equal, written in point number 2, and this angle is 90 degree, this angle is 90 degree, so both are 90 degree, so this is point number 1. So we can say that triangle ABM is similar to triangle PQN, and this is by which property? This is by A axiom. So this is by angle axiom over here. So since we have said that these two triangles are already similar, then the sides are in the ratio. So since the sides are in ratio, we can say that AB by PQ is equals to AM by PN over here is equals to BM by QN over here. So this is from the proof that we have already done. So we can say that these are equal. Now in this particular case, we don't require this one. BM by QN, we don't require this one. We just require this one. Now we will understand why we only require this one. So let me mark this as point number 2. We are going to use the point number 1 that we already discussed. We are going to use point number 2 over here. Now, since we have already proved that these two triangles are equal, no, not equal, these two triangles are similar. Since we have already proved that these two triangles are similar, let us quickly find out the area of these two triangles, basically the triangle ABC and triangle PQR over here. So let us do that. Now let us find out the area of triangle ABC and triangle PQR over here, and let us keep them in the ratio form. So area of triangle ABC by area of triangle PQR. Now in this particular case, we can say that area, whenever we calculate area, we apply the formula half into base into height over here. So we are going to do that. It is basically half into base. Now over here base is BC, so we are writing BC over here, and height is AM, so we are writing AM over here. Similarly, in this particular case, we will write half into QR into PN over here. So we applied the formula over here, half into base into height. In this particular case, we can simply cancel half on both the sides, that means numerator and denominator. Now the next thing is, we can say this becomes BC by QR into AM from PN over here. Now in the previous proof, now just before this step, we have already proved that the side, that means AM by PN, we have already proved that AM by PN is equals to this AB by AB by PQ. We have just proved that this side AM by PN is equals to AB by PQ over here, and this is from number 2. And from point 1 we already know that AB by PQ is equals to BC by QR over here. So in the place of BC by QR, we can easily substitute this value, that means AB by PQ over here. So let us do that. AB by PQ, this is from point 1, and in the place of AM by PN over here, we can simply substitute AB by PQ. So let us do that. This will become AB by PQ. So this becomes AB by PQ whole square. So this is the proof of your area, that area of triangle ABC by area of triangle PQR is equals to a side ratio whole square. This you can prove for other cases also, like you can just substitute, instead of AB by PQ, instead of BC by QR, you are substituting AB by PQ. So let's not do that. Instead, this part is equals to this and this is equals to this. So we can substitute BC by QR and we can prove that also. So this you can say for all the 3 sides. That means we can consider all the 3 sides over here and we can prove that. So this is the proof of area of similar triangles. In the upcoming videos, we are going to discuss the next thing, that means the numericals based on this similar triangles. So let us keep till this much. Till then, goodbye.